Okay, all right, before I get started with this, I think Frank mentioned this already, but I live in Atlanta, and the Atlanta Java User Group, which is a nonprofit, runs a little conference called DevNexus. Now, how many people in the room have been to DevNexus before? Okay, wow, that's almost a third of the room. That's great. For the rest of you, why have you not been yet? Okay, so this is a low-cost community conference that you can see the date there, April 9th through 11th. And how many people in the room are speaking there this year? Justin is not, because Justin, it's a little dicey. But we have a bunch of folks who are speaking at the conference this year. We're going to have 14 tracks, and we're projecting about 2,000 people. So if you've heard of Java 1 before, it's basically gone now. Everyone says that this is the new Java 1. So please come. It's not as expensive as Java 1, and you're not in a shithole city like you're not in a city like San Francisco, actually, or Vegas, right? I hate Vegas too. So anyways, it's in Atlanta. It's super cheap. It's about an hour-and-a-half flight if you're lucky to get out of the airports here. All right, please join us. 14 tracks. We have loads of great workshops. What's the workshop you're doing, Victor? I've forgotten now. Yeah, so Apache Pinot is a real-time data analytics platform. There, nailed it. See, brain still works. But we have some other ones. Daniel Hinos, who's a Java champion, is doing architectural design. There's a Jakarta EE. Some of you may know this guy. Who's heard of Venkat Subramanian before?
Never heard of him.
Never heard of him? You should get out more. We have a really nice workshop on Open Rewrite. How many people heard of Open Rewrite? Just out of curiosity. So this is basically a code transformation and refactoring platform. It's open source, et cetera, Quarkus, and then SpringBoot 3, and then a security workshop. Anyways, and then there's like too much content to even bother showing you because it's literally pages and pages of stuff. Yes. Okay. So without further ado, let's get on to our presentation. All right. So shit, I almost tripped on something and unplugged it. Uh-oh. All right. So how many people use Spring Boot here? Okay. Let me rephrase the question. How many people do not use Spring Boot? Okay. What do you guys use out of curiosity? What's that? Boutique. Oh, I've never heard of that before. Have you heard of that? Oh, okay. There are a couple other hands. Yeah. I'm actually surprised. Surprisingly, a lot of people say Drop Wizard. And like at least a few people in a room of this size will say, "Oh, I use Drop Wizard." And it's like, wow, really? Okay. I mean, there's nothing wrong with it. It's just surprising because Spring Boot or Jakarta EE or whatever, or Quarkus. Yeah, you don't work at Red Hat anymore. You don't have to pimp for them anymore. So, oh, Micronaut. Okay. And there's one more hand over here. No Spring. What do you guys use? Just plain Java? Okay. Well, you're wearing a Duke shirt, so I don't know if that's if it's credible. I'm a Tar Heel. What's that? Okay, that makes sense. It's servlets and JSPs. Okay. So I think Frank already asked how many people are using Java 21. So I'd just like to take a quick survey. How many people are still running Java 6 in production? We'll start like in the 2000s, right? Anyone using Java 6? It's okay, you can raise your hand. Fine. Okay, Java 7. Okay. What's that?
My
previous project. Fair enough. On production still. Okay. Got you. Java 8. Okay, of course. Right. Java 11. Okay. 17. Okay, that's the other half of the room. And then there was one person running on production with 21, right? Okay. You have all of them. Okay. I got you. Okay, cool. All right. So my name is Pratik Patel. I live in Atlanta. I help run the Atlanta Java User Group for my day job. I lead the developer relations team at Azul Systems. How many people have heard of Azul before? Okay, so about half the audience. So what we do is we only do one thing. We only make JVMs. Well, we have a new security product coming out called vulnerability detection, but I'm not going to talk about that too much. You may have read one of my books, but most important thing is if you have a follow-up question, that's how you can reach me on Twitter or on LinkedIn. Okay. And do work for Azul. We make a couple of different JVMs. We make an open source JVM called Azul Zulu, which is 100% free based on open source. Anyone can use it. And it's important for this specific presentation because it's the only production-ready JVM that supports CRaC or CRaC to do that fast boot for Spring, which we'll talk about in just a few minutes. Okay. And we have a high-performance product, which is called Azure Platform Prime. It is essentially a high-performance VM, and some of our customers, for example, when you're running Apache Kafka on Prime versus OpenJDK, you get 30 to 40% speed up just by replacing the VM, which is pretty interesting. The way we can do that is we have our own proprietary JIT compiler called Falcon, and we have our own proprietary garbage collector called C4, and hundreds of low-level optimizations which are not in OpenJDK. So if you're running big data, or since in New York, people like do something called finance, high throughput, low latency systems, right? If you need any of that stuff, also a great fit for running your applications, okay? So how many people want a free beer after this meetup? It's just show of hands. I'm going to run over and grab a table afterwards. Monk McGinn's is, how far was it from here? Like 2 blocks? Yeah, Justin and I came down together. We did a few tequila shots before we came here just to loosen up. So, yeah. All right. So, and I apologize for the misspelling. I don't know why that says Springbok. That must be the autocorrect. So, how many people have heard of CRaC or CRaC already? Okay, good. So not most folks in this room. So what I want to do, I'm going to steal some of Justin's time, even though this was supposed to be a lightning talk, to just give you a few fundamentals about CRaC or CRaC before we get into the Spring Boot specific part. Okay, so CRaC is, oops, sorry, I dropped this. Oh, before I forget, I'm going to go through this rather quickly. So if you want to get a more detailed analysis and code and all that kind of stuff of all the stuff that I'm going to talk about, my colleague Garrett Grunwald has written this excellent article on how to use CRaC with Spring Boot and what some of the nuances are that I'm going to speak about here, but he goes into more detail in this blog post, and that's on fujay.io. If you just do a search for Spring Boot 3.2 and CRaC and Garrett's name. Actually, I'll drop a link to this in the meetup page or something, or I'll have Frank send it around on the mail list so you can go grab it and have a read, okay? So CRaC stands for a coordinated restore at checkpoint. So essentially what this does, the best way to describe this is everyone in this room has a laptop, I assume, a thing that you program on, right? So when you finish work at 6 or 7 or 10 p.m. or however late you work during the day, what you do is you close the lid on your laptop, you go and do whatever, you come back the next morning or later in the evening, you open your laptop back up, and what happens? It's at the exact same point in time at which you left it. This is essentially at a very low level what CRaC or CRaC allows you to do. You take a snapshot of a running Spring Boot application, and then you say, I want to restore from that snapshot, and it will restore from that exact point in time at which you told it to take a snapshot of your running Spring Boot application. Yes? It's, if you're running Spring, it is Spring Boot specific. But yes, it is not necessarily, CRaC itself can be used with any framework that supports CRaC, okay? Or if you're just running, if you're just like writing plain Java using, to run like batch files or batch processes, you can use it for that. It can be used for anything. It's not Spring Boot specific. So that's a good question. Yes? No, it doesn't. CRaC is a lower level technology. Yes. Exactly. It's specifically for faster startup or instantaneous startup. Okay, I'm going to get into that in a little bit. Okay, yeah, no problem. Yeah, and like these guys, if you have any questions at any point in time, just let me know. Happy to take a minute to talk about it. Okay, so let's talk about essentially what CRaC is built on. I don't want to talk about GraalVM and AOT aside to say don't use it, because in my opinion, there are too many trade-offs with GraalVM. For example, reflection doesn't work when you use GraalVM based image. Well, it does to a certain degree, but you run into some edge cases with it. Whereas when you're running with CRaC, there are no compromises that you need to make. You're running a full-fledged VM with JIT and garbage collection and all that kind of stuff. It's not a binary that you do with GraalVM. I'm sure everyone has heard of GraalVM since it's been around for, what, 7, 8, 10 years now? It's been around for a while. But CRaC is based on a low-level Linux technology called CRIU, which is something in user space. Do you remember what it's called, Justin? I can't remember. It's a little late for me. It's almost past my bedtime. So now the thing with CRaC is that you do have to do something, or the framework that you're running on does have to do something to be able to support it, right? So how many people in this room are software architects? Anybody? There must be at least a few, right? So what's the golden rule of software architecture? I know it's a trick question, but just throw something out. Pick one. Yeah, don't be a CRaC. Okay. So in my opinion, the golden rule of software architecture is that software architecture is always a series of trade-offs. Or the way I like to say it, that's what Neil Ford says. You may have heard of Neil Ford. He's written a bunch of books on software architecture. The way I like to paraphrase it is that nothing in life comes for free. And that includes in software. Okay. So with CRaC, you get this ability to have instantaneous startup, but the trade-off that you're making is that you have to do some stuff, or the framework that you're running on has to do some stuff. It essentially has to implement the CRaC API. And let's have a quick look at what that kind of looks like. Okay? Of course, I already talked about you do checkpoints. You can do them in code, or you can take a checkpoint in code, or you can use a command line signal to tell the JVM to create a restore checkpoint for you. Okay. All right. So this is something that was led by Azul and created by us, but most importantly, it's been donated to OpenJDK, and it's now a community effort. So it's not just us who are working on it, even though we were the originators of the project. It is in OpenJDK, and my guess is that other VM vendors will implement this CRaC API in their JVM at some point in time. Okay, so it does come with an API. Yes, the short answer to your question is yes.
Can you repeat the question?
The question was, it's been merged into the OpenJDK code base. That's the question, right? Yeah. And the short answer to that is yes. But the way that OpenJDK is kind of structured is that it's kind of modularized. So it's a module that you can import and build an JDK with. Okay? But the short answer is yes. It is in the OpenJDK code repository. Okay. So it's 100% open source. It's all there. Okay, sorry. Let's go to the next one. Right? And the way that you take a checkpoint is you use the top flag to say, hey, this is where we're going to store the checkpoint, and the bottom flag is this is where we're going to restore from a checkpoint that we've already previously taken. It does require code changes, as I mentioned before, but the main thing that these code changes need to do is you need to close and restore connections. So for example, if you have an application which has a file handle or a Unix socket handle, or has a database connection, network connection, the CRaC API gives you a hook to be able to go close that cleanly. And then when you start it up using the restore checkpoint, guess what I'm going to say? It allows you to restore that network connection to a database, for example. Okay, so that's the code changes that I was referring to that you need to make. Okay, but to be honest with you, when we talk about SpringBoot, if you're just using kind of the standard SpringBoot libraries, everything is already done for you. Right? There may be some esoteric library that is not supported by the Spring folks themselves that may require some work, but if you're using any of the standard stuff, if it's Spring JDBC or Spring JPA or using the Kafka connector or whatever it is, all that stuff has already been, basically the Spring team has done all this stuff for you already. So if you're just using box standard Spring Boot, and you want to use CRaC, then you can use it without making any changes to your code, which for me is golden because I like for somebody else to make changes to code that I don't have to maintain. Maybe that's just me, okay? So this is the kind of stuff, if you have your own framework, Micronaut already supports CRaC. Quarkus kind of supports CRaC. We've been trying to get the Quarkus team to have better support for CRaC, but for some reason, Max is resisting. I don't know why. Maybe they bought into GraalVM. But anyways, that's a story for when we're at the bar. Okay. So that's the whirlwind 5 minutes on what CRaC is. Okay, does anybody have any questions at this point? Okay, so one question that comes up usually at this point in time is, I'm running Java 8. Can I use CRaC? The answer is no. I'm running Java 11. Can I use CRaC? The answer, again, is no. This is something that came in with JDK 17. So you have to be using 17 or higher to be able to use CRaC within your application. Okay, so for those of you who are lagging, unfortunately, you will have to upgrade to it. And the other thing with this, specifically with SpringBoot, is that SpringBoot 3.2 and above support CRaC. So if you're running an older version of Spring, then you will not be able to use CRaC whether or not you're using JDK 17 or not. Okay, so the two dependencies or requirements that you have for running CRaC with SpringBoot or having a CRaC capable SpringBoot application is that you have to be running at least JDK 17 and you have to be running at least Spring 3.2. So that begs the question, how many people are running Spring 3.2 already? I know it only came out 2 months ago. Okay, so one person, 2 people. Okay, so how many people are planning to migrate to Spring 3.2? Okay, well, that should be everybody, but at least I would hope so. Okay, so let's talk about Spring Boot and CRaC for a few minutes. Again, Spring Boot 3.2, Java 17 plus only. And what's interesting is the Spring folks went the extra mile and they actually created something called auto checkpoint. So obviously the maintainers of the Spring and Spring Boot project know their framework reasonably well. And they said, hey, why don't we actually make it even easier for the developer and have this thing that allows the dev team or the developer to just say, hey, just create a checkpoint for me. And so they have this auto checkpoint feature. But there's a limitation with that, which we'll talk about in just a minute. Okay. So we'll talk about it now. So with auto checkpoint, and again, this is something very specific for Spring Boot 3.2. Is what it does is you give it a flag, which I'll show you in just a second, and it just takes a checkpoint for you, and then it brings down the VM. Oh, this is one important thing about CRaC. And this doesn't matter if it's Spring Boot or Quarkus or even your own framework. When you take a checkpoint, a CRaC checkpoint, it will shut down the VM afterwards because essentially you're closing all connections and file handles and stuff like that. So the VM is actually, that application is no longer usable, okay? So that's just one thing to keep in mind is that when you take a checkpoint, it's not like, oh, we're taking a checkpoint, our app will keep running it. The app will actually be brought down afterwards, okay? So the idea is that you take the checkpoint somewhere in your CI or CI pipeline, you have that, you stuff it into a Docker container. We can talk about where you're supposed to put the checkpoint files or the restore files if you like. But you basically, typically what people do is stuff them into a Docker container or somewhere on the file system. And then you say, this is what we're restoring from, and it will bring it up from that point in time. Okay, so the auto checkpoint feature in Spring Boot 3.2, unfortunately, is not optimal. Okay, so the reason for that is because when the auto checkpoint is taken, it's taken at the middle phase of the initialization of your Spring Boot application. Okay, so I'm not sure why they did this, but I'm sure they had a good reason. I haven't had a chance to ask them yet, but it basically will take a checkpoint when the Spring framework itself is initialized, but before all lazy Spring objects and lazy singletons are initialized. Okay, so and if you're familiar with Spring Boot, then you know that a lot of the stuff happens non-lazily, and then a lot of stuff happens lazily as you go and basically read the bean factory and blah blah blah. Right. So what I'm trying to say is that the optimal place to take a checkpoint for your Spring Boot application is once your Spring Boot app is fully initialized, whatever you're using, whether you're using the Kafka library or like the JDBC or the JPA library wrappers in Spring Boot, when all that stuff is fully initialized. So that means all the metadata, which is quite a bit depending on the size of your Spring application, right? You know that you generally create this giant constellation of Spring objects in different service beans and whatever in Spring that do all the stuff for your app. That's the point in time that you actually want to take your snapshot. That means your snapshot will be bigger, but that means your app will be 100% ready to service its first request, right? So auto initialization, auto checkpoint takes it when the low-level Spring Boot framework is initialized, when the entire Spring Boot application is ready to go and what we call ready for first request. That's when you want to typically take your snapshot. And this is something at this point in time that you have to do manually. I think what will happen over time is that someone will figure out a surefire way to be able to do that initialization, to take that snapshot when the entire Spring application is fully initialized, right? And I'll tell you why I think you want to take it at this point in time. Okay. So first, how do we set up the auto checkpoint? You pass it in a flag. Spring.context.checkpoint equals on refresh. This is something very specific. So on refresh is essentially that phase in the Spring Boot or Spring Framework initialization when all the low-level Spring configuration has been loaded, but not necessarily your applications service beans and everything have been initialized. Okay, So this is an example of how you set the auto initialization. Okay, and this is some verbiage from that blog article in detail. So basically, after the auto checkpoint is when let me see if this works. There, sorry, it kind of works. All non-lazy initialized singletons have been instantiated, and this is what, well, if you use Spring, you know what this means, okay? But this is in the blog article. All right, so this is the money slide, as they say, right? So with Java 17 and the Spring Pet Clinic application that's used in the blog article, it initialized in about 4.6 seconds, let's say 5 seconds, okay? And that's with Java 17. Java 21 actually initialized a little bit faster just by using newer versions of the JDK, because as you know, every new version of the JDK, there's more and more low-level optimizations which are in it, et cetera, okay? Now, with this Spring Pet Clinic application and JDK 21, with auto checkpoint turned on, when that checkpoint was restored, it took about 400 milliseconds to start up. But when we did a manual checkpoint after our entire Spring Boot application was initialized, you can see that it was an order of magnitude faster, actually, okay? So this is why I think it's better to take, I mean, if you're gonna go to the lengths of implementing CRaC, you wanna get it as fast as possible, right? Especially if you're running in environments where you want it to start fast, whether it's Kubernetes or Cloud Functions and other stuff like that. Speaking of Cloud Functions, how many people run Cloud Functions, whether it's on AWS, GCP? Nobody runs Cloud Functions on production? Which platform do you use, out of curiosity? Use Lambdas, yeah. And Lambda also? Okay. So have you looked at, and I'm going to totally forget what it's called now. They actually have a CRaC implementation on AWS Lambda, and it's called snapshot. Have you seen this yet? Okay, so are you deploying your Lambdas, or are you writing your Lambdas using Java or something else? Yeah, okay, whatever. Okay, right, so I have good news for you. So now what you can do is you can write your Cloud Functions for Lambda using Java, and on the configuration page, there's a checkbox that says use snapshot. And what it does is it does all the stuff I just talked about with like auto checkpointing and all that kind of stuff for you automatically. Right? Because in Lambdas, you don't use SpringBoot, right? Or if you do, you're doing it wrong. Hopefully, this isn't being recorded. But if you're using a big framework like SpringBoot and you want to use it in Lambda, it's not a good idea. You know, okay, right? So, but yeah, you should check it out because you literally kick that and it uses CRaC. Unfortunately, Amazon does their own thing. It's they use Corretto and blah blah blah, but it's not available. It's just available on snapshot for Lambdas. But anyways, it's there. So this tech is actually being used already by people, right? Specifically by AWS Lambda. Okay. So, but in terms of environments, this can be used anywhere, right? You're not limited to just like you're running your monolith or running inside of Kubernetes or running inside of a container as a service like AWS Fargate or Google Cloud Run or what's the Azure one called? Help me out. Is it Azure Containers? Their CAS solution? I think it's Azure Containers, right? So actually, I really like using CAS as opposed to Kubernetes, but Kubernetes versus CAS is a little bit of a religious war that should be discussed at the bar and not here. So, okay. Anyways, that's pretty much it. I'm going to turn it over to Justin, and while he's setting up, I can take a few more questions. So, yes, go ahead.
Wait, questions, microphone.
Oh, yeah. Question, microphone.
Okay. Why anyone would like to use it? Like, I'm just asking from my experience, you know, I work in this bank, you know,
yeah.
And, it's not like we're starting application every second, you know, it's basically every week if you are agile, let's say, or more frequently, but rarely more frequently than once a week. Sometimes the system is starting itself, but generally you don't do it so frequently. So why it would matter for us this 4 seconds? Well, maybe for Pet Clinic, that's 4 seconds, but for a bigger application, it would be 20.
Right, 20 seconds.
Yeah, 20 seconds, or maybe even 1 minute.
Okay.
Who cares really? Like,
yeah. Okay.
Why would you?
So the question is if I'm running a standard monolith type application, let's say, why do I care about starting up in 40 milliseconds versus 20 seconds? So that's obviously 2 orders of magnitude faster, but does it really matter? Okay. So at this point, this is an architectural question, right? Or system design / architecture question. right? So if you're running, and I assume this is a distributed system where you have multiple nodes, so you can bring, like, say if you have 10 nodes, you can do what's it called, a rolling deployment. So you bring 2 nodes down, you bring it up with the new instance, et cetera, et cetera. You basically do a rolling update of your system, startup, whatever, reboot, right? So the short answer to that question is you don't need to use it in that specific scenario. Okay, it's not necessary to go to that length unless you actually have some kind of issue with it. So the reason why people are interested in CRaC is basically for having more elastic compute. Okay, everyone is familiar with the term elastic compute, right? Basically, your servers can scale up or down, and maybe not constantly, right? But let's say somewhat frequently. I don't want to say frequently, right? So in an environment where you're running like a container as a service, where AWS or GCP or Azure is managing how many instances of your CAS application or your application that's deployed into that container as a service platform, it manages the up and down. So that's on this side of the spectrum. On the far side of the spectrum, where it's really needed would be Cloud Functions, right? Because Cloud Functions, typically
Cloud Function platform will
spin up
instances and spin them down very aggressively. Right. So that's where you don't want somebody to wait 5 seconds or 20 seconds
for your app to come up. So that's and then you have the in between, in my opinion, which is when you're running in a Kubernetes cluster and you have auto scaling turned on. Kubernetes detects that you don't have a lot of traffic, so it brings down some of your pods to save you money, save you resources. And then when traffic starts building up, it starts spinning clusters back up, or sorry, it starts spinning nodes back up within the cluster, right? So at that point in time, that's when you care about how fast it starts, okay? Or if you're running, like in certain batch scenarios, like if you're just running in just a plain Java application, or maybe using Spring Batch or something, and you want those batch processes to spin up very quickly, do some work, and then spin down, right? So yes, it's a great question, and I think that's less of a technology question than what are my requirements and how do I architect the system. So if I were running a monolith, I probably wouldn't use CRaC. It's just not needed. I don't care if it takes 5 minutes for this thing to start, because I'm running 20 nodes concurrently, and it is what it is, right? So, okay.
One more question.
Yeah, one more question.
Any other questions for after this?
Sure, go ahead.
Just a quick question. How would this work on containers? Because most of the time scaling works in data centers where you just tear down the container and then install a new one. And I was actually confused when you talked about pods, because I was kind of assuming that pods are just a construct on top of containers. So
That's
if
right.
pods are taken down, that would usually mean that the containers are destroyed and then new ones created when the pods are coming up. So
right. Yeah. So in terms of this, I think of this as being a little bit outside of the whole containers and pods thing. So for me, containers are just packaging and deployment model, right? So when you release a new version of your application, you're going to build a new version of your app that's in a new container, right? Is that what you're asking, or are you asking something different? You deploy. The instance of the container gets destroyed, not the actual image of the container, though, right? Right. You're just destroying the instance of the container. Yeah. Right, but you won't do that anyways, right? Yeah, okay. Sorry. Well, let's pick it up a little bit later, okay? All right, Justin, all yours.
Oh man.
Here, let me get my laptop though. And my phone. And where'd you put that bottle of tequila?
Drink it. Am I still in the meeting there, Barry? It looks like maybe I'm not.
Here, you want to take
Am
this
I?
off?
I don't see anything about sharing my screen.
Okay, somewhere on your Zoom screen, you are co-host.
Oh, there it is. Okay.
It's on Justin.
It's on me. But I'm going to share my screen. Share. Oh, the big green button on the bottom.
Yep.
All right. If I share my whole desktop, how terrifying is that? Nope, that's Zoom. All right.
Sure you have to.
I'll leave that in the meetup page. Okay,
I'm seeing something different.
are you?
Your other screen.
You're seeing the other screen? Okay. Oh, I see. You're showing. I wonder if it's because it's whatever. Come here. Stop sharing. Share. All right. I'm not going to share the browser because
Share the.
I'll just share my ID because that's where all the good stuff is. The browser just has notes. Do you see that now?
Okay. Yes.
Okay. I don't want to see that. I want to see this. Okay. Anyways, I had like stuff on there, but it's not important. And the camera's not going to follow me. So my name is Justin Lee. I used to work at Red Hat, which is where a lot of this stuff came from. As of last Monday, I now work at Datadog, doing more bytecode stuff, which is fun. But what I want to show you tonight is how many of you have used Quarkus? It's all SpringBoot people here. That's fine. Quarkus is, well, it's amazing, but it is it's phenomenally complicated to build for reasons. And so we did a lot of like really interesting things with our GitHub workflows, which I borrowed some of those, and then through some of my own experimentation, I figured some stuff out. Like all of this you could figure out if you wanted to go through and read, dozens of pages of GitHub's documentations, which is what I did. So I'm going to try and jumpstart you to give you an idea of what's out there and show you what can be done, and maybe it'll take some stuff away. So has anyone who's used GitHub Actions here? Some of you. Okay. All right. So we're going to start from the very basic structures all the way up to some weird stuff towards the end. So hopefully you won't feel lost. None of this is terribly Java specific, but this is a Java users group. I'm a Java guy. So all the examples are in Java, but it's just GitHub Actions. So a workflow is defined in YAML. It's not my favorite, but it's what they chose. And it has this basic structure. Like you give it a name, you give it on. So this tells it like how is this workflow triggered? It's going to execute on some event. Then you can define jobs. You give it a job ID. You can name it something different. The job IDs can be like something very succinct or whatever. But eventually you're going to see the name of your particular job on the web page, and you might want something a little bit more descriptive than step one. Like you might be like build the software, build the test, whatever. You can name it whatever you want. You don't have to name it, but you can. And then each workflow has a number of steps. Pretty basic. So that is what the basic structure looks like. So for a Java job, so we're going to give the entire workflow a name. We're going to call it build Java, and we're going to run every time we push to the repository. So every time you push a commit, it's going to run this workflow and it's going to do stuff. So we're going to run a job called build. Build is a nice enough name. We don't need a new one, so we'll just use that as the job ID. Every job needs you have to tell it what to run it on. It might default to something, I don't quite remember, but all of mine run on Ubuntu latest. There's a Windows runner, there's a Mac runner. You can specify specific versions if you're doing like some like Ubuntu specific. I need 1804 or 1810. If you need those, they're there. Some of the older versions are falling off because it doesn't make sense to support them all. But if you're building Java, it kind of doesn't matter. So Ubuntu latest it is. And so we're going to run some steps. The first step, of course, when you want to build software is you want to check it out. So it's going to spin up a container in the runner environment, and it's going to run this thing called checkout. Now, this is a predefined action that I think GitHub, Microsoft provides, and it'll check out your project. There are some configuration things you can do with this. You can actually literally Google this exact text, and you'll come to the definition for this checkout action. There's some configuration there, like if you only want like a shallow checkout, if you have like a enormous, a project that has like 18 years of history, checking it all out can take a while. So you might only want to check out, the first revision or the last month's worth or whatever. You can configure that going. And of course, we're going to build a Java project, so we have to set up our Java. And conveniently, there's an action for that already. And so we just trigger that. Now we're gonna tell it, we're gonna configure this particular action a little bit. We're gonna build with Java 17, and we're gonna use this particular distribution. There's a number of options for the distribution, and we'll see them later. But they're kind of what you would expect. There's Oracle, there's Azul, there's, I think Corretto's an option now, but we'll see a handful of them. Now this is newer with the version 3. Who's built a Maven project? The first time you build it, what happens? Download the internet. You don't want to do that every time your CI runs, because depending on your project, that could take a while. So this just says, I want to cache. And in this case, we're going to tell it cache the Maven artifacts, and it knows where to find those. So that's all you have to do. It'll configure your M2 repository. So next time it runs, it'll have that cache, and any new dependencies will get downloaded, but it'll use the old ones. And this just tells it which server to use. It's almost always going to be Maven Central, but you might have your own internal repository for whatever reason. Or back in the day before it died, was it JCentral? I forget what it's even called, bin trays thing. But it's gone now, so it doesn't matter anymore. So the next step, we're going to call it run the build, and then we're just going to run that command. It used to say, I think, Maven install, but Andres got very mean and demanded we change it. So there it is. Okay, so that's a basic build. There's nothing terribly exotic about that. There's basically only one thing that's happening. So you might want to like split up your job into particular, your workload into separate jobs, but you want to be able to make sure that one runs before the other. So we're going to define some dependencies. So this looks like what we just saw. Here's build, we're going to cache, we're going to run this bit. Now, what I like to do personally, because I have a couple of open source projects, I like to push snapshots every time I build. So like if I get a user request like, hey, there's a bug, I can go fix what I think is the bug fix, and then I can go back to my users and say, hey, use this snapshot, see if it fixes it. If it truly does fix the entirety of their issue, then I can do like a formal release. But I like to push them out to the snapshot repository every chance I get. So in this case, we're going to run a job called snapshot. It's going to run on. And there's a new item here called needs. And this is basically just where you define your dependencies. In this case, we only have the one, and we have to make sure that this job runs before snapshot does. And then snapshot does kind of all the same bits as the last one. And then it just runs an extra step of deploy. And now we'll push it out to, in this case, the snapshot repository. I actually also do this when I do releases. I do all my releases on GitHub Actions. I just push a tag, and I have a workflow that builds it, tests it, and pushes it all out. But yeah, we'll get to that. Right. Now, whenever you're building a project, if it's Java, you kind of don't really care like what your operating system is. But if you have external dependencies, if it's a database, if it's, I don't know, it could be Kafka, you can have like multiple external dependencies that you support, but not necessarily simultaneously, right? You support different forms of the database, Postgres versus Oracle, whatever. So you want to build a matrix, all right? Now this one is a little bit contrived because I want to show you what it looks like, not necessarily something that's terribly useful. So we're back to our build. We're adding a new thing called a strategy, and we're going to define a matrix. So the matrix is pretty, what is the matrix? It's pretty freeform. It can be whatever you want, right? These are not predefined keys that you can use. You define whatever you want to call it. I chose OS for the operating system, which Java version you want to run on, which distribution. Here's some of the other distributions. There's Adopt Open JDK. If you're like a J9 shop, you want to run on J9, that's an option. Liberica. There's one or two or three or four more. There's a bunch of them. So now that we have this matrix defined, we can start to do some interesting things on it. In this case, there's 3 different operating systems that this particular workflow is going to run on. It's overkill for a Java job, but there are reasons. And now all we tell it is we can say run on matrix, just is the reference name for this, and then whatever particular value you want. In this case, it's OS. And then when we check out down here, you can see the Java version. We're going to refer to whatever the matrix, and it gets injected with each one, and then distro, and then everything else, of course, looks the same. So what this ends up looking like in a real job, now this is actually this is a snapshot from some months ago of the project that I work on in my spare time, Morphia. If you're Mongo people, Mongo Java, Morphia. Anyways, so as you can see here, we have a whole bunch of things going on here. My job, my workflow definition has the job name is test, which is not what you saw in the YAML, but you see test, and you can see these are the versions. So here, this is the Java version. This is the MongoDB driver version in my case, in the Mongo server version. So I want to test across the multiple different configurations, because in that particular case, sometimes the interaction between like what's offered at the server level versus what's offered in my API, there might be some disconnect. And well, I want to make sure that my newer Morphia code runs on older Mongo servers, for example. So I build a matrix out of it, and as you can see, there's a lot of them. And you can see I have a couple of, I run some code audits, check style, that sort of stuff. And we'll see this in a minute, but I do a build first. So I build on, in this case, Java 11, because that's what this version supports. And then I run it across different JVM versions just to see. So I actually split up in this case. I run a build, but I don't run tests. And then in this particular column here, you can see where I'm running the tests. And literally all I'm doing now is I'm running tests against the bytecode that I compiled in the previous build step. And I cache it in between, and we'll see what that looks like. And as you can see, this is the snapshot. It did not run for whatever reason. That's what the little slash means. And then neither of these actually build either. These, we'll see what that looks like later, but these are actually firing external events to other projects to go run those against what I just released. So that's what the matrix looks like when you look at it on the Actions tab in GitHub. Okay, so with this is not a Morphia sales pitch. So this is the context in which I do all this stuff. So there's a new version of the driver coming out in my particular case. And there are some known breakages with the new driver. And I want to pre-test against those versions to see like what changes do I need to make so that when their version drops that I can support it as close to day 0 as possible. But the problem is like I know it's going to fail, right? Because there are breakages, known breakages coming. So I want that job to fail because I want to know like where that breakage happens, where it affects me as a Morphia author, but I don't want it to kill the overall build, right? If everything else still passes, then I want to go ahead and push the snapshot or push the release or whatever. So you can flag a job as optional. The way that happens here is in your matrix, you can do this include, and you can define specific values for different things. In this case, we're going to run with Java 20, because when I wrote this, Java 20 was not released yet. It's that long. All right, so I had a flag called experimental. Again, I picked that name. You can call it whatever you want. Optional, flaky, whatever semantically makes sense in your particular context. You just want to know, right? And I give it a value of true. You can see matrix true, or matrix.os. And then this is where the magic happens. There's a value called continue on error, which is where you tell GitHub Actions, what do you want me to do if something fails? The default value is to stop, right? Because if a test fails, then you don't want to push anything. In this case, in certain cases, I want to continue because I'm not terribly concerned about failures. So here you can define, here's the experimental value that we defined. And you'll notice I do equal true here. I hate that particular syntax in my Java code, and I've spent the last 60 years not writing that sort of Java code, and so I did not do the equal true to start with. But where that really starts to fail is this experimental value doesn't always exist. For these other parts of the matrix, that value isn't there. So when it goes to evaluate this text, if I just said matrix.experimental, it would give it an empty string. which is not a reasonable value for continue on error. And it gave weird errors in that case, which did actually stop the build. So here I can say equal true to give it like an explicit value to compare against. So if matrix experimental does return an empty string equal true is false. So let's stop the build at that point. And the rest of it looks the same. And so what that looks like here, you can see these builds all worked, and these two builds did not. You can see the ugly red X. You can see this true value is the value for that experimental flag on the matrix. You can't see it here because I only took like a small screenshot of it, but the overall run on this particular workflow is green. It passed because these were experimentals. So if you have those particular, for whatever reason, it's a new integration to a new data store or document processing, whatever, and you're trying to get it working, you can add it to your flow to see where are we on this, but don't stop it because it's under development. Just like it is as a continue on error as true. Okay, so in my case, I have a lot of different things. I have kind of some ancillary projects around Morphia that I work with, but I want them all to basically operate the same way. Like once I get my workflow scenario defined, like I really like it. I spend a lot of time on it. I want to use it everywhere. Now you could copy and paste that YAML file to each project that you work on. And that's what I did for a while, but it gets really tedious. Like if you're fixing like a typo with this or that, you have to remember like, oh, 6 other projects I have to go fix. Not ideal, but you can do a reusable workflow. So this particular workflow is reusable. And you will notice the only real difference is instead of on push, now it's on workflow call, right? And this is basically saying that one workflow is going to call this from somewhere else. But as you can see, the rest of it looks the same, right? This is everything we've been looking at so far. So that's the reusable build. Here's the original build. You can see that's the only real difference, right? Now, this doesn't use the reusable build yet. It still has its own stuff defined. So what does it look like to reuse a build? It looks like that. You can see it went from this whole bunch of stuff to that. And it's we'll get to some more complicated stuff. Now, this deserves a little bit of conversation. In my case, it's a very simple text because I'm just trying to do an example. In practice, what this looks like is I have my own, a separate repository on GitHub, and you reference it by the GitHub user or project. And then you can actually give it a version. If I was responsible, I would tag versions and then pin it to a particular version and upgrade as I go. But it's mostly me and I know what's going on. So every time I push a change to my workflows, all my other projects get those updates because I use the master branch on that repository. For more complicated requirements, you might want to pin it to a particular version. And then you can play with the workflows elsewhere. And when you get it to work in the way you want, you just come bump this version up to whatever that new version is. This is basically, I think, a tag or a branch on that other repository. So that's what that looks like. All right, conditional steps. You don't necessarily want to run everything all the time. When people fork Morphia, for example, I don't want them trying to push a release, right? Because they're not going to have credentials to push to Maven Central, so don't bother running it, right? So you can do things like this. There's an if you can add to your step. And then this is pretty free form inside these brackets. There are a number, dozens of these variables that you can use that are pre-built as part of the GitHub infrastructure. In this case, you can check the actor, like who is the user. In this case, like if we only want to run it whenever I push something or I do whatever, you can restrict it by a particular username. You can restrict it by the event name, which is a little bit redundant from like the on stuff up above, but not entirely redundant. It does make some sorts of sense here and there. And then the rest of it just looks the same. But if this doesn't evaluate to true, then you'll see the little slash. In fact, that's why you saw the little gray slash thing on the screenshot earlier, is because that was filtered out, because the evaluations didn't return true. But then all the rest looks the same. And you can do, so this is on the entire job. You can like conditionally execute a job if you want. You can also do it on a specific step. So in this case, again, if you want to like sign your artifacts, it only makes sense to do it inside your repository as opposed to like a fork, or even within like your organization. Like at Red Hat, like I had my own fork of Quarkus and I did my stuff there. The main repository did stuff, including like signing artifacts, and it has their secrets and keys and passwords that I didn't have. But my fork didn't, so I don't run them on my fork. So you can do things like check which repository this is running in and filter it out, and you can run GPG or whatever the step it is you want to do in that particular case. So back to matrix builds. So if we go back to our matrix, just to refresh memories, this is what it looks like. We have matrix.java, blah, blah, blah. But we can also reuse builds with a matrix, right? So our matrix here, you can see, is the same. And now we're doing uses, and that we're referencing that external workflow like we just saw. And now we're going to pass in values, right? So we're going to use that with these values, and we're going to pass in matrix, distribution, which version, which JVM we're going to use, which version of Java, which operating system. We're going to pass those on to the reusable workflow, right? So we go back and look at this, and then our reusable workflow then just references variables like you would see. The problem here is, as you can see, there's no matrix in this workflow. It's going to die because the matrix is not defined, right? So the way you fix that is by defining inputs. And it starts to get a little bit verbose in this, but it's YAML. You do it once. So in this case, we're going to find some inputs. We're going to find the distro that you just saw when we called here, distro Java and OS, right? So we're going to come in here. There's distro Java and OS. You can tell whether it's required or not. You can give it a type. I haven't really found type to be terribly useful in my particular cases, but I can imagine scenarios where like the type of the input might matter in certain scenarios. So you can define it like it needs to be a Boolean, it needs to be a number, whatever. But you can give it a default. So if I call this reusable build and I don't pass in any values, I can give default values to those particular inputs. And you can just go down the list and you see them all. In my case, none of them are required because if I don't pass anything, there are certain reasonable defaults that I want to use. And then down here, instead of calling matrix, you just refer to it as inputs. And you can have as many inputs as makes sense. In the various iterations of my own workflows, I've had, 7, 8, 10 inputs before I finally like dialed it back to something reasonable. But however much you need to pass in, you just pass them in, and it works just like everything else, like we saw with the matrix. So a working example, this is an older version, but this is pulled from the Morphia workflows that I developed some of this with. There's a new workflow dispatch. Normally workflows, you push it and it just runs, right? But if you're trying to like debug your workflow, you want to be able to like manually force a workflow to run without having to push another like meaningless commit. So this is a different type of event, workflow dispatch. And if you have this, there'll be like a little drop box up on the UI. It's like run this, and you can pick like which branch you want to run on depending on how your workflows are defined. So you can like manually run a workflow. In my case, I would like want to rerun things because I would change the upstream workflows to do something better. But I wanted to run the Morphia workflow against that updated guy. So it was just simpler to do this. All right, so in this case, this is where my workflows live. All the workflows live in the .github directory of your project, specifically .github/workflows, and we define whatever YAML file. You can name it whatever you want, and give it a version. So this is the full like reference to your reusable workflows. And I do think it supports a URL, so it could be probably off anywhere else. But all my stuff is internal to GitHub, so you can just reference my particular user. It could be an organization, and then the project within that org or that user. So mine is creatively called workflows because I didn't want to think about it too much. And I'm going to pass in particular flags. So this is where I tell it to save the artifacts, because we saw that like the cache maven on the setup Java task, right? But that's just the repository, okay, over the local Maven cache. Especially when you're working with snapshots, it starts to get really tricky because Maven will pull whatever's in your local cache, or it might pull down what's up in Maven Central. And when you're working with snapshots, which one that comes from can be unclear at the time. So I went the extra step, probably overkill, but it works for me, of saving the class files that get generated. And we'll see that in a second. And this is just where I tell it to save the build, right? And I give it a name. And I'm passing specific flags in for various reasons. So I'm gonna pass in this variable called Maven flags, and it's just a couple of flags pass in. A little bit specific to the Morphe build, not terribly critical. Right, so this is where I just build it, but I don't test it. And then now I want to test it, and I depend on the build. This could just be the one like we saw earlier. You just have the one dependencies. In other cases, I have multiple dependencies, but it's YAML, so you just define it as a YAML list, right? So depending on how many of you have, you can change the syntax. There's the matrix. This is quite old because now there's a Mongo 705 out. Different versions of the driver, and then we're going to reuse that particular workflow, pass in these values. You can archive certain artifacts once a workflow is done, you can archive stuff. Like if you have a test run and there are logs generated, and you can see, oh, the test failed, but you want to go like look at the logs to see what happened. You can dig through the stack trace. There's a window you can watch the run if you like scrolling through things. But even like simple builds tend to generate a lot of output if you're using something like Maven. So you can actually archive whatever you want, right? You just need to be able to reference it, the file path to it. In this case, I'm telling it to archive it, and I'm giving it unique names so that the matrix jobs don't clobber each other, uploading artifacts to the same name. Again, I'm passing flags. In this case, I'm limiting snapshots to particular branches as opposed to forks and such. I'm running test. Now, this is where it gets interesting. So I mentioned that I do releases off of my branch. And if you've ever pushed a Maven Central, you know there are certain things you need to have, right? You need to have your public key installed on your workspace. There are usernames and passwords and this and that. But you don't want to put that in your YAML file because whatever's in this GitHub workflow YAML file, it's public, right? It's just you can go to GitHub and see everybody's workflow files. So you don't want to put your secrets there because they're secret. So you can actually define secrets as part of either an organization or as part of a particular project. And the secrets are write only. So like once you like give it a name, you put in a value, and you click save, you will never see that value again. Even as the admin of a group, like you'll never see that value again. So make a note of it somewhere, put it in one password, whatever it needs. But the point is like no one ever sees that value again. When the action runs, it'll pull it out and run it as part of the workflow. And when you see if you ever watch a job run, and you will, you'll see stuff go by, and when it calls these workflows, you'll see where it tries to pass in like the so type password. Like but it's going to log it, but it's smarter. You will just see a bunch of asterisks there. It'll mask out the secret values, and it's pretty good about it. But this is how you would pass things on to those remote workflows. I have it run. I update my documentation every time I run. That's what this is doing. So remember that workflow dispatch? You can actually do it manually as well, or not manually, but programmatically as part of your flow. So once my build runs, my tests pass, and everything's good to go, I want to update the documentation because I also keep like snapshot documentations in JavaDoc online. So every time a successful snapshot build runs, I push out the updated documentation as well. And this just says to go, I use Antora. It says, use this workflow to dispatch a job to this other particular repository. And I pass some secrets, and you give it like which branch to use. So that is what the Morphe job looks like. And then, so the reusable form of it looks like this. And this is complicated. I wouldn't necessarily recommend doing it this way, but it works for my particular kind of odd needs. I define my inputs on a workflow call. These are all, I believe, all optional with some defaults. So I have like reuse build, save build. This is how I decide whether or not I'm going to build and test, or if I'm just going to build or I'm just going to test. I've simplified this a little bit, but I didn't want to update the YAML here and then have it like have what's here out of sync with what's in my head, and have you guys have to sit through and watch me try to figure out why I'm confused. So anyways, so these are the code audits that I run. Setup. If I'm not reusing the build, like I only want to run these audits on the first time. So if I'm running the tests, I've already run the audits. I've already figured out that the code has an unused format, unused import. I'll get the right word. I can't tell you the number of times jobs have failed because I forgot to remove an import because it checks for that. So, but I only want to do it the first time I build in the very early parts of my flow. So if I'm reusing the build, meaning I'm running the test only against the compiled bytecode, don't bother running the audits, right? And that's how I tell it to run my audits. So the build, that all looks the same like we've seen. In this case, we're going to build and test. So in this case, if I'm not saying save build and I'm not saying reuse the build, do it all. Maven update install, not verify because I'm a masochist. But this way I can say build and test in one step because I use this for more than just Morphia, this particular workflow. Now, if I want to build without tests, there's another if. It checks this, if I'm saving a build, run this step, in which case you can see I'm running the install, which I know Andres is going to love. And I'm going to skip the tests because I just want to build, right? This lets me build against the target JVM and then test against other versions of it. It's a little less necessary now because I'm moving to Java 17. All right. But we want to save it so we can reuse it. And if I say save build, which is what I did here, there's an action called upload artifact, which will upload artifacts. And you just tell it what you want to archive. So in this case, I'm going to give it a name. And I'm going to give it a distinct name with build and then the run ID. Every run, especially like in a matrix, has a different, like it's a very large number, but it's unique. I don't know what the numbers are. It doesn't entirely matter. But it generates a unique name. So when it archives it up, you can get that specific one. And I am going to tell it to archive everything under every target directory you find. So any class files built, any resources processed, any jars built, whatever is underneath target is going to get archived, right? And you can give it a retention. I forget I think the default is 7 days. But honestly, this could probably be 1 because I'm going to build it, archive it, run tests. If they don't pass, I don't need to keep it around forever. But depending on what you need it for, you might set this to 30 days or 90 days or 1 day, whatever. But the default, I think, is 7 days. So just be aware that if you want to stick it around, you might want to change this. Now we're reusing the build. In some scenarios, we're going to pass this value as true. So there's the flip side of uploading is you can download an artifact, right? And you just give it a name. And you can see we give it the same name that we used to the upload artifact. So this lets me build in one step, and in this other, like the big test matrix, I can go download those particular class files for that run. And then when I run the test, I can just run Surefire directly. So I'm not building, I'm not processing resources, I'm just literally running whatever tests are there. I'm collecting the logs, again, using upload artifact. Now this is interesting. There's a function called failure. So this says if a previous step has failed, let's run this one. If all the previous steps have succeeded, I'm not terribly interested in the log files because everything worked. And then I want to make sure that there is an archive name defined because without it, it might generate a default name, but it'll be something inscrutable. It will make no sense to you whatsoever. So it might be hard to find after the fact, right? So we're going to upload the artifact with, in this case, I give it logs dash and then whatever archive name I passed in. I forget what I'm using, but it's some combination of the JVM Mongo driver matrix. And then I tell it I want to upload every log, every error. Because in this case, I was actually running a local version of MongoDB with the data directory underneath my target directories, which lets me then pull this .log and .error files are actually Mongo logs and error files. So if Morphe had generated a bad query or whatever, the most useful information apart from the stack trace will be in the actual Mongo logs. So this lets me capture those logs and I can go download and view them after the fact if the build should fail. And again, 3 days. If I haven't looked at the job failure in 3 days, I'm too busy. Come back and rerun the job, sort of a thing. Okay, so custom tools. Every developer has like favorite tools they like to use locally, right? But they're not going to be on the GitHub instances because there's billions of these little tools, right? So you need to be able to install them on your workspace when you're running an action. So I borrowed this from my colleague Erin Schnubble. She has a project where she actually uses, I think, Jetpack to publish her artifacts as opposed to Maven Central because it's simpler. I prefer Maven Central, but not everyone does. So in this case, she used to find a few jobs with some inputs. You can actually schedule, and this is called anti-freeze because with Jetpack, it like freezes artifacts and they're just there. So this is called anti-freeze, where she goes in and unfreezes them so she can like prune out older versions. Not terribly important, but kind of humorous. But you can schedule it to run, and it's just, if you're familiar, who knows cron tab? The Linux people, yeah. Like I still have to look at it, like what does each section mean? But I mostly understand it. But this is just like your standard Linux cron tab syntax. I have, apart from running my docs every time I push a job, I actually have the docs run nightly because sometimes synchronization between the snapshot that got pushed and the docs running, they're not always in sync. So I run it with each push, but I also run it nightly to make sure that I catch anything that didn't get caught because of the synchronization issues. Okay, so she's going to use YQ, the portable YAML processor. There's a utility called JQ for like JSON query. This is the exact same tool, except it's YAML instead of JSON. But it's useful if you want to like interrogate and extract certain elements of a YAML document out on the command line. So that's what she's doing. Mike Farah was nice enough to write this action to set up YQ on your runtime instance. And here, she's going to say if the update snapshot tag is true, we're going to run this. So after this installs, you're going to come down here and you can see here she just runs the YQ command as if it was just always there. Because as far as the workflow is concerned, it has always been there. We just happened to install it the step before. So you can do whatever it is that you want to do. We'll see an example here in a minute. I use JBang for some complicated stuff, but it doesn't come on Ubuntu by default, so I have to install it. And here's where she unfreezes it, passes in secrets and stuff. So not every utility you want is obviously going to have an action. You can run, if you want to run like apt-get install on your Ubuntu or whatever, you can do that because it's just the run command will take whatever's in that that text value and it'll literally exec it on. So you can install things manually if you want, you know, the old-fashioned way, or sometimes you'll get lucky and there's an action you can use because this is much simpler than what it might be. Okay, so dynamic builds. There's a lot here, and it's a lot to maintain. Can be overwhelming. I love testing and I love coverage. So in my particular case, I don't necessarily want to track every time the Java driver releases a new version for Mongo. Like I'm not that interested in what they're doing over there, but I would like to test against it. So I want to dynamically generate my matrix, right? Especially like new server versions come out. Like I really don't pay attention to that. But I want to be able to find those versions and test against them in some ways. So we're going to define a dynamic matrix. So here you can see I'm installing JBang because Max was nice enough to write an action. I think it was Max. So I'm going to install JBang. Now what I'm going to do is I'm going to go run this script, build matrix, and I think I don't have that in here, but we can. It's a JBang script. It's out there if you want to go look at it. What's in it is not terribly important, but it does go out and it does some stuff and it outputs some information on the command line. And what this line does is we're going to echo this, the output of all of this, to a thing called GitHub output, which is a special environmental setup on your GitHub action. And you can reference that later, which we'll see. So I'm going to go find like, what are all the server versions out there? I also go find out like, what's the latest snapshot version? Right now it's just 5.0.0 snapshot because that's what they're working on. But eventually 5.0.0 will release and there'll be like a 5.1.0 snapshot. When that happens, I will automatically start testing against that because I dynamically go out and figure out what is the latest snapshot version for that driver. Yeah, you may not need that sort of flexibility, but it's there, right? And again, I go find the latest version, latest production version, because I don't always necessarily upgrade immediately on master branch. Now, once I collect all those off into GitHub output, there's also GitHub env, which is slightly different, and there's some different semantics around how to interact with that. I haven't found that terribly useful in my particular use cases, but it is there if you want to go look at it. GitHub output has been the most useful for what I need. And then we can define outputs. In this case, we're going to do the version matrix, which is this Mongo versions thing that we saw, because this particular one actually goes out and finds out what are all the latest releases in each branch. So the 4.0, 5.0, 6.0, 7.0, what's the latest 7.02 versus 7.03, for example, because I'm a little persnickety that way. And we define, what the snapshot variable is. So how that looks in practice, then like once you go do all that, how do you use it, right? So we added a step here for matrix, which we'll see now. Yeah, because matrix is what runs those JBang scripts in the last demo file. This is where you get to use all that. It gets a little verbose. Can everyone read that? I know it's a lot. I'll scroll over. So instead of having like a static value in your YAML file, this is an expression you can run. In this case, we're gonna needs is a context that's defined here, as it turns out. So we're gonna, in the context of needs, and in the job matrix, we're gonna get the outputs and specifically the value in version matrix. Now, version matrix returns basically it's JSON, but it doesn't look like JSON because it's just a string as far as actions is concerned until you call it from JSON, and then that'll parse it into like an actual object structure in memory. In this case, an array of values, and then it'll use that for the Mongo axis in the matrix. And then I do my include. I want to test against the latest driver. What did 5.0 break in me so far? So whatever that particular snapshot version is, go define that. And then I've switched from experimental to optional because why not? And then the rest of it looks the same. We just, instead of manually typing in all the stuff in a YAML file, we've dynamically discovered it at runtime for all the convenience. But then you use it just the same way. And you pass things around. Here we're passing in like which version of the Mongo server we're going to use, which version of the driver we're going to use. So now I've dynamically generated, 2 or 3 of the axes that I need to test against. And that lets me automatically track changes that happen before I notice they happen. And then once I figure out, oh, there's a new version of the driver, I'll manually update Morphia to use that new version. But in the meantime, I'm already testing against it because this is how it works. So then what that looks like here, as you can see, this is Java version, the Mongo server version, the driver version. And as you can see, it just works through all those different values that were generated dynamically. Here's the one done here. If it's not lost behind people's heads, it won't let me scroll. Here's the optional one for the driver. You can see here it's pulling 5.0.0 snapshot. It happens to be the latest one. And then the other steps below. Right. It starts getting a little bit more complicated. I do some caching here. I forget why I added this. It's actually a little bit more confusing than probably needs to be. But again, it's all part of like dynamically at generating. Oh, yeah. So I have one project that's using Maven wrapper to do things because I need 4.0.0, and at this point it was 4.0.0 alpha 7, which you can't use on the runners because it's going to use like 3.8.9 or whatever this like production is. But I needed to force it to a particular version.
No,
Okay, I'm almost done. Like 2 more files, 1 more file. In this case, I go and figure out, is Maven wrapper present? If so, use that instead of just Maven. Slightly overkill. Oh, we're almost out of time and battery, so this works out. So you can get like really complicated depending on how you want to do things. All right, one last thing, and then I'll be done with questions. If you ever had to manage Maven dependencies, it gets really old, like tracking every version that gets upgraded, whether it's a security update or new major release or whatever. So GitHub has a thing called Dependabot, which I really love. And you can configure it to run daily or weekly or whatever. In my case, I run it daily. And what it will do is you tell it which ecosystem you're using. If you have a node project that you're using, you can have it look at your NPM dependencies, or if you're Python or C# or Rust, it knows how to handle those dependencies and those build systems to find updates. In this case, we're using Maven because why not? And it will open pull requests for every dependency that's out of date. It'll open a new pull request that will automatically update your POM or your Gradle file or your cargo file or whatever. And it'll file that pull request for you. Then you just go in, that looks good, I'll take that. And it'll do it for you. And you can define, if you need across different branches, you can define which branch you want to do. We're not going to look at it because it's a little bit complicated and questionable, and we're almost out of time. I actually have a workflow that will go through, and if Dependabot has upgraded a dependency for me, I will have it auto merge the Dependabot changes if tests pass. And that's great on master because master is experimental and blah, blah, blah. You probably don't want to do it on production branches because I did for a while, and I actually had to upgrade a dependency like SLF4J from like 1.0 something to 2 something, which is what you want to use, 2.0, but on if someone's downstream using a minor patch upgrade and suddenly they're getting like this massive upgrade to something else, this guy came back and said, you can't do that on a patch release. And he was right. So you don't want to do it everywhere, but on master, why not? If test pass, upgrade it, and it'll just save you some headache. But Dependabot will do that for you automatically. All right, that is literally the last file that I had. I know there was a lot. Let me, oh, you can see it. Okay, there's some resources. Here's some additional comments. I went over some of this, most of it. Yeah, it is visible. Don't put your secrets there. You can encrypt files. In the Quarkus build, there was actually like an encrypted file in the .github. It was like the settings XML, which had like all the Maven central passwords in this net, but it was encrypted. So if you go to the GitHub repository, it's just a blob, right? It's a binary file. You can't read it because it's encrypted. But with the secrets, they can actually decrypt that as part of the workflow and then configure their passwords and stuff. So here's some references. Take photos or ping me on Twitter and I'll show you. They're bit.ly links, which I apologize for, but they were like really long and they wouldn't fit on the screen otherwise. But there's like the official workflow reference, which is fantastic. It's where I learned most of what you saw. These are the workflows that I use. You're welcome to use them. I would, if you're interested, I would recommend forking it and using your own copy, because I tend to be a little cavalier sometimes in my changes as I'm experimenting with things, and you might not want those for your project. And if you want to see them in action, this last link is the Morphe repository, which you can see like the current state of what my workflows are and how they interact with the upstream stuff. So it's all there for reference. And that was my battery, Diane.
Cool.
Nailed it.
All right, so we have time for 2 short questions for Justin. Does anyone have a short question for Justin?
Auctioneer style.
So GitHub provides this for free, or?
Yes. Yeah, the question is, GitHub provides it for free, and the answer is yes. there are certain like limitations, like on the Quarkus team, you know, it was a massive build. So we ran into some limitations because there were just too many. On my Morpheus stuff, I've never had it throttle me because I don't do that much. So for most of your projects, you're probably not going to run into it. If you're a company using GitHub, you might run into it and might have to explore some sort of like contract with GitHub. But for the most part, everything is free.
And do we have a second short question? Wait.
For internet, yes. You mentioned about the Dependency, and you kind of like trusted if some of the dependencies would be successfully pass the test, you will auto merge. Is it like how you like put this in? Do you put this information into release notes somehow after that? Like do you use this type of approach for also for doing the release notes for or everything goes from the commits?
I don't necessarily list those as such, but it is something I do want to document. I'm trying to get JReleaser working properly. There's some disconnects between what I need and how JReleaser actually works. But as part of that release process, you would get like the commit log of like all the updates for that particular release, as well as the issues fixed off of GitHub. So you can document that after the fact, which is a little bit simpler than trying to file a separate issue for every dependency update, because that gets old.
All right. We have time for 3 more things. We have to thank Justin, do the raffle, and have beer. So first up, thank Justin.